Hi class, today we are going to learn about proportion and indirect measurement. Sometimes in life we can't measure things that are they're too tall, buildings or flagpoles or trees. We can estimate them using proportions and indirect measurement. So what we're going to do today is I'm going to go through some of the examples in this packet with you, and then you go back and work the rest of the problems. But it's important that you stay with me through the examples and don't just work on the problems because I want each of the examples worked out and for you to be following along. Okay, so let's start with the first example on the first page where it says an athlete on the school football team can run 20 yards in 2.9 seconds. During the last football game, the athlete ran 64 yards for a touchdown. If the athlete's rate of speed remained the same, about how long did it take him to run for the touchdown? Okay, so the first thing you're going to do is label the table. And in this case, it's a table, but I really want you to think of it as one of our proportions that we always do. Line equals line. And then you're still going to label what you're comparing. And in this case, you're comparing yards and seconds. So fill in this side with yards over seconds, and then that means the other side would be yards over seconds. Because as always, in a proportion, you want to be consistent. If you're comparing yards to seconds, on the other side it has to be yards to seconds. Okay, and then go back and fill in the information that you know, and you know that 20 yards in 2.9 seconds, so you fill in 20 over 2.9, and then during the last football game, our athlete ran 64 yards, so think about where should that go, the 64 on the top or the bottom. Since it's yards, it should go on top. And then we're trying to figure out how long did it take him, so that would be our x seconds. Okay, so there you are set up with your proportion, and you guys are really good at doing this now, is cross multiplying, finding the cross products. So we have 20x is equal to 2.9 times 64, which should give you on the calculator 185.6. Then you look at your equation and both sides you want to divide by 20. So then x is equal to, so take your calculator, 185.6 divided by 20, and you'll get 9.28. Remember what you're looking at is x right here is in seconds. So this is a multiple choice question, so you want to find what's the best estimate here, what's the best one? It would be A, 9.3. Okay, so you're still doing, in this one it's just a ratio, it's comparing yards to seconds. You set up your proportion, cross multiply, and solve. And make sure you have a reasonable answer. Okay, so I want you to skip, don't start working on the next problem. I want you to skip through number 10, go right past number 10 until you get to the next example at the top of this page, where it has the two rectangles. And it says, sometimes geometric pictures are used in proportion problems. Find the dimensions of the missing side.
She needs your.
Okay, so you can think of the first figure, the large figure, as number 1, and the smaller one is number 2. So we're comparing rectangle 1 with rectangle number 2. And then what are we looking at? We're given the length and the width. So, or you can think of the short side to the long side. I think sometimes that works better because kids get confused with length and width. It just depends how it's worded. So remember, you're setting up your proportion. Line equals line. So you're comparing short to long. So if I look at rectangle number 1, I have 18 for the short side and 24 for the long. In rectangle number 2, they're giving me the 12, which is the short side, and I'm trying to find the long side. So x. So at this point, you put your numbers are in their table. You can either find scale factor, or in this case, I'm going to cross multiply. So find your cross products. 18x is equal to 12 times 24. Put that in your calculator. 18x equals 288. So at this point you divide both sides by 18. And your missing side x is 16. 16 what? 16 centimeters. Look at it up here. Does that seem like a reasonable answer? Yes. And so circle C. Okay, go down, scroll down to the next problem, example 2. This one's a little bit different, so make sure you're really paying attention. The base of the larger triangle is 75. Find the base of the smaller triangle. Well, first of all, over here it says outline each triangle in a different color. Okay, so I outlined the smaller triangle in yellow and the larger triangle in green. So you can see those. Do those look similar to you? Okay, so yes, they should have the same angle measurements. Right here, they both share the 90-degree angle, and then they would have the same angle measurements. Their sides are proportional. So let's figure out what they are. So let's look that we're comparing in the small triangle. So this is the small triangle and the large triangle. Okay, in the small triangle we're going to be looking at the slanted side on the left and then the base. Okay, and so then of course we're going to be comparing the same things on the large triangle, the left side to the base. So in the middle is where I put my proportion. And then I just fill in the blanks. So I look at the small triangle. I have 25, and then this is what I'm looking for. This is my x, the length of that side, the base. So I have 25 over x. And then I look at the large triangle, and my left side of the large triangle is 50. It's the full length there. So 50 over the base, which is 75. See right there. Okay. At this point, you're set up with your proportion. You can do your cross products or look for a scale factor. In this case, I think the scale factor would be the way to go. How do you get from 25 to 50? Multiply by 2. So how do I get from x to 75? What do you multiply by 2 to get to 75? If you know that, which I do, x would equal 37.5. Okay, if not, go ahead and do cross products because you guys are very comfortable with that. So x is equal to 50 times x equals 25 times 75, 1875. And then divide both sides by 50. And you get the same answer, x equals 37.5. Okay, so within this triangle, there's two triangles, the small triangle and the large triangle. They share the same angle measurements, and they have the same congruent angles, and then their sides are proportional. So we can compare the left side to the base and the left side to the base for both of them. Okay, next I want you guys to scroll down to number 14. It's not an example, but I do want you to look at this one. And you can see I've highlighted it. You might want to do the same right now to point out the two triangles that you're comparing. So remember, you might label small and large triangle. And then think about that you're doing the base to the right side or the right side to the base. It doesn't matter, of course, which way you label it as long as you're consistent on both sides. But what I wanted to say is on the red triangle, you can see that the right side is 0.9 and the base is 1.2. So if I do right and then base, and I'm comparing 0.9 to 1.2. That's half of my proportion. Now on the other side, if I look at the right side of the large green triangle, I'm comparing this part, which I don't know, which is my x. And then I'm looking at the base. If you look at the base of the green triangle, it's the full length. So you have to decide what is the full length of this. It's 1.2 from here to here, and 2.4 from here to here. Okay, so if you think about it, you would need to combine those, add those together to find the base of the large triangle. Okay, so that's a big hint right there. Okay, so at this point, go ahead and scroll down to the last example. Okay, so turn the page. It's at the top of the next page. And this is where indirect measurement definitely comes in handy. A tree cast a shadow of 24 feet, while Ralph cast a shadow of 8 feet. If Ralph is 6 feet tall, how tall is the tree? So based on where the sun is and the length of the shadows, we can, estimate what the height of the tree is. So this is what we're trying to find, is the height of the tree. Okay, what are we comparing? We're comparing the shadow to the tree, the height of the tree. So the height to the shadow. Of course, I'm abbreviating height to shadow. And this is the man, and this is the tree. I know it seems like a lot to label, but at the same time, it will keep you from making mistakes. So we look at the height of the man, which is the 6 feet. And then we look at the shadow, and his shadow is 8 feet. So 6 over 8 is equal to what over what? So the height of the tree is x, and then the shadow of the tree is this part right here, would be 24. Okay? Looking at that, we can decide whether we want to use scale factors, or if we're using scale factors or cross products. In this case, if I look at from 8 to 24, you think about that you would be timesing by 3. So you can do the same thing. How do you get from 6 to x? Times by 3. So 6 times 3 would give you 18 feet. And so you think to yourself, does that seem like a reasonable answer? From 6 to 18, you multiply by 3. From 8 to 24 is multiplying by 3. The scale factor is 3. Okay, of course you can cross multiply and get 8x is equal to 144. Divide both sides by 8 and get x equals 18 feet. Okay, so the rest of those problems are going to be more like this, where you're comparing the height to the shadows for indirect measurement. Okay, so your job is to fill in the rest of this packet. We will go over it in class tomorrow when I'm back. Work through, show, I want the chart filled in. I want you to show what you're comparing, the height to the shadow, the right side to the base. Whatever it is that you're looking at, I want you to show your work. Take your time. Use your calculator if you need to. You can look for scale factor or use cross products, and do a good job. Okay, and I'll see you tomorrow. Bye.